The rapid increase in urbanization gives rise to huge challenges across cities around its different facets, including transportation, resource consumption, and infrastructure. Data used in conjunction with visualization and analytics can help significantly with these challenges and to better understand cities and improve quality of life. However, existing techniques focus on identifying features or events in the data, or exploring the mobility of predefined entities, i.e., the focus is on understanding the data. The goal of Urban Pulse, on the other hand, is to understand the city in the context of different datasets. This is accomplished by looking at the intensity of pulses of activity from multiple datasets across different time steps covering multiple temporal resolutions. Our approach combines techniques from computational topology with visual analytics to efficiently identify, explore, and analyze pulses across cities. This is accomplished by first modeling the urban data as a collection of time-varying scalar functions over different temporal resolutions, where the scalar function represents the distribution of the corresponding activity over the city. The set of high persistent maxima of this collection of scalar functions are then used to identify the locations of the most prominent pulses in the city. We then characterize the pulse at a given location as a set of beats, which captures the level of activity at that location over different time steps and resolutions. The beats of the pulses are then used to analyze and compare pulses. The visual interface allows for the exploration of pulses across different scenarios within a city and between cities. Here we load flicker data for summer months in both New York and San Francisco and see the trends of activity. We can then filter activity by day or by hour. Blue dots represent New York and orange San Francisco. The pulses are ordered by level of activity for the selected time range. We can compare summer with winter and understand the differences in activity across the city. Additionally, filtration can be done within the map. Here, we are looking at an area of Midtown New York that includes Times Square, Rockefeller Center, Grand Central Terminal, and Bryant Park. On the pulse monitor, we can see the similarities and differences of activity. Rockefeller Center and Times Square are extremely similar across hour, day, and month, whereas Grand Central Terminal is not similar to any other New York location. Instead, it is most similar to the heart of the Castro District in San Francisco. Interestingly, Rockefeller Center has hourly activity levels close to Alcatraz. Finally, we can use the Urban Pulse framework to rank spaces in one city according to their similarity with spaces in another city. Here we select Bryant Park and see the spaces most similar in San Francisco. We can move the selection to see similar spaces for the other New York spaces. Urban Pulse is set up to explore any spatial temporal data set, not just Flickr and taxicabs as demonstrated here. By allowing for exploration of the pulses and beats of cities, Urban Pulse creates a new framework for understanding how people occupy, use, and move through spaces. This can inform urban design, zoning, public policy, and infrastructure planning.